Okay, so today we're going to talk about P.5, solving equations graphically, numerically, and algebraically. Okay, this is kind of stuff you've done before that we kind of need to review, obviously. So let's jump right into it. Let's do example number one. Let's do example number one. Example number one, the question is 2x squared minus 3x, 2x squared minus 3x plus 2 is equal to 0. Or is it minus 2? Minus 2. It is minus 2 is equal to 0. Okay, so graphically, you would just go into your graph, you would put y1, y is equal to 2x squared minus 3x minus 2, and graph it and find out where it meets in the x-axis. And the way you would do that is that you're going to go up like this, and it's going to look like this. So you know your answers are here where x is equal to 0, right? The x-intercepts. So this is what the solutions are, the x-intercepts, or what we call the roots, also called the solutions. Okay, so you would use the trace function in your calculator to trace at which exact point this becomes 0, and you would figure out that way. So that's how you would do it graphically. Okay. Algebraically, it also asks you to confirm this algebraically. So algebraically, what you would do, and this is what you would do. So this is a quadratic equation. So the first step in quadratic equation is you try to factor it. Okay, so you would factor this. Looks like it's going to work this way. All right, so if I go minus 4 plus 1, so I end up with minus 3, right? Minus 4. If I multiply these two, I get minus 4. Multiply these, I get plus 1. Minus 4 plus 1 is minus 3, so there we go. So your answer is, this is the same as 2x plus 1, x minus 2 is equal to 0. So this is how you would factor it, okay? That's how you'd factor it. So so this times this is equal to 0, which means that either this is 0 or this is 0, okay? So either this one is 0 or that is 0, so either 2x plus 1 is equal to 0 or x minus 2 is equal to 0. So on this one, you would move the negative 1 over to that. X is going to be equal to negative 1/2. Over here, you move the 2 over, you get x is equal to 2. So you have two answers here. Okay? So let's say you were not able to figure this out. If you were not able to factor it out, doesn't mean that it's the end of the world, right? Doesn't mean it's the end of the world. What's our next step? Our next step is that, well, if we can't factor it, we just toss it into the quadratic equation where x is equal to negative b plus or minus square root of b squared minus 4ac over 2a, where this is a, this is b, and this is c. So I'm going to get negative b is negative 3, plus or minus square root of b squared minus 4 times a times c over 2 times a. I get 3 plus or minus square root of, this is 9, minus and minus cancel out, they become plus. 4 times 2 times 2 is a16 plus 16 over 2 times 2 is 4. 3 plus or minus square root of 25 is equal to 4. Square root of 25, as we all know, is 5 over 4. So it's either 3 plus 5 divided by 4 or 3 minus 5 divided by 4. 3 plus 5 divided by 4 is going to be equal to 2. 3 minus 5 is minus 2, divided by 4 is minus 1/2. So we get the same answers, okay? So every time you get a quadratic equation, unless I tell you to solve it using a specific method, this is how you approach it. You try to factor it, you factor it for about, I don't know, 20, 30 seconds, you can't figure it out. then you immediately go to the quadratic equation. Okay, so that's example number 1. Example number, what's next? That was example number 1. So if we go on top of page 41, there was a zero factor property. This is what we talked about, right? When you factor it, it's either one of the terms have to be 0. Okay. Quadratic equation. Quadratic equation is an equation that can be written in the form of ax squared plus bx plus c is equal to 0, where a, b, c are real numbers and a is not equal to 0. Why can't a equal to 0? Because if it did, then it would not be a quadratic equation. It would be bx plus c, and it's a linear equation at that point, correct? All right, example number 2. Example number 2, we're gonna try to solve quadratic equations using square roots. So we have 2x squared minus 1 squared is equal to 9. Okay, so in this one, we would go ahead and just take the square root of both sides. If I take the square root of this, and the reason why I can do that is what? Is because it is something squared is equal to something else, right? This does not have to be 9, it could be anything else, right? It can be 7, it would still work, right? So let's work it with 7 and see what happens. If I have, well, let's work it with 9 first. If I work it with 9, what do I get? If I take the square root of both sides, I get 2x minus 1 is equal to plus or minus 3, right? Because the square root of 9 is plus or minus 3. I move the 1 over, I get 2x is equal to plus or minus 3 plus 1. So if I divide both sides by 2, I get x is equal to that. So when it's plus, I get 3 plus 1 is 4, divided by 2 is 2. When it's negative, I get negative 3 plus 1 divided by 2, negative 1/2. Okay? And the reason why this would work if it was 7, it's just the same way, right? If it was 7, I'm going to take the square root of both sides, plus or minus square root of 7. So 2x is equal to 1 plus or minus 7. Divide both sides by 2. And that's my answer. Okay? I'm still using the square root, right? I'm taking, because I was able to get into a form of something squared is equal to a constant, right? Okay, that's example number 2. Now let's go to what we call completing the square. There's a purple box underneath the page 41. This is something that absolutely baffles you guys for some reason. So let's see what we can do. Completing the square. Completing the square is when you have an equation that looks like this. Okay, it's going to be a little different, slightly different from what you're going to see here, but it's basically the same thing. Okay. So if I have this, I'm going to use what is completing the square. So what I'm going to do is going to leave these 2 terms on the left side and move the constant on the other side. So it'll be negative c like this. Okay? And then from here, I'm going to view this as, what I'm going to try to end up with is this. I want this guy to end up like this. But if I do this out, what do I get? I get x squared plus bx plus b squared over 4. Okay? So what am I missing? I'm missing this guy here. I'm missing this guy. So I'm going to add this guy to both sides. So I'm going to go x squared plus bx plus, I'm going to add that. So I'm going to get this guy. That's what I'm going to look like. So this is what I'm going to get, right? I'm going to get that guy. So now what do I get? So I can now go ahead and say that this guy here is going to be x squared plus, this guy is the same as x plus b over 2 squared. And over here I'm going to get what? 4b squared minus 4c. All right. So from here I'm going to take the square root of both sides. I get x plus b over 2 plus or minus the square root of b squared minus 4c, well, I'm going to go like this, over 4. This is the same as square root of b squared minus 4c over 2. So now I'm going to move this guy over. I get x is equal to negative b over 2 plus or minus square root of b squared minus 4c over 2. I have the same common denominator. B squared minus 4c. So this looks awfully familiar, right? So I came to this, and this is what? This is the quadratic equation if a was equal to 1, right? Because this would have been a, and then there was an a here, right? 4 times 1 times c. So this is the quadratic equation if a was equal to 1. So in other words, the completing the square in this form only works when a is equal to 1, okay? But again, you can see how completing the square is tied to the quadratic equation, okay? So the key here is to be able to see this and divide this guy by 2 and square it. Because this is what that is, right? It is the b divided by 2, and it's a squared form of that, b squared divided by 4. So that's what you're adding to both sides. Okay? So let's see if we can work that using example number 3. Let's do example number 3, see if we can do that. Example number 3, I have 4x squared minus 20x. Plus 17 is equal to 0. Okay, so what I'm going to do, I'm going to go ahead and move the constant over first. So I'm going to get 4x squared minus 2x is equal to minus 17. Okay, the problem is we do not have an a is equal to 1 point here, so let's go ahead and make this 1. So in order to force this to 1, I'm going to divide everything by 4. X squared minus 1 half x is equal to negative 17 divided by 4. Oop, I have the wrong question. This is 20x. 20x. So this would be 5, right? So this is where we are, right? Okay, so my b is negative 5. So I have to divide that by 2 and then square it. And that's what I'm going to add on both sides. So I'm going to get x squared minus 5x. I'm going to add this guy on this side. Since I'm going to add this guy on this side, I have to add it on this side too. Right. So this guy now becomes x over this squared. And over here, what do I get? I get 25 over 4. So I get 25 minus 17 over 4. That's 8, so I'm going to get 2. Right? So I take the square root of both sides. X minus 5 over 2 is equal to square plus or minus square root of 2. Now I move this guy over, so x is going to be equal to 5 over 2 plus or minus square root of 2, and that's really your answer. Okay, so that's how you do that. And in the middle of page 42, there is the quadratic equation, quadratic formula, I mean. I'm not going to go over that, we've already done that one, so we'll move on. Okay, so let's go to example number 5. Example number 5. So first of all, let's go to page 43. On the top, it says how to solve quadratic equations algebraically. Again, you try to factor it. If you can't factor it, then forget about 2 and 3. Just go straight to using the quadratic formula. Okay? Right. So that's how you would work that. Okay, example number 5, you solve the equation that graphically, so solve this guy graphically, x cubed minus x minus 1 is equal to 0. So what you would go ahead and graph this guy and see where it meets 0, or it meets the x-axis, correct? That's how you would do that. Approximating solutions of equations numerically with tables. Solving using this table. Okay, solving using table is, so it's numerically, so we're talking about how do you do this numerically. All right, you would graph it first and find out kind of where it's at. And you can look at it and it looks like it's in between 1 and 2. So I would start doing a table between 1 and 2. Find out where the value actually switches from negative to positive or positive to negative. So in order to switch from positive to negative or negative to positive, it had to go through the x-axis. So that's what you're looking for. You're looking for the point where it switches over, and that's what you're looking for, okay? And how you would do that is in the book. I'll let you read that. There really isn't nothing earth-shattering there. Okay, solving equations by finding intersections, okay? Solve the equation, example number 7. Solve the equation, it's equal to 6. Okay, so what they're saying that if you want to solve this, you can go ahead and you can graph it. This is y is equal to 6, and looks like it's going to end up like that, okay? Because this here is going to be y is equal to the absolute value of 2x minus 1, and you're trying to find out where this guy is equal to this guy, right? So that would be the intersecting points, those two right there, and you would just go ahead and trace it. You would use your trace function to see where exactly they meet. Okay. If I asked you to solve this algebraically, you would say this is either plus or minus 6, because this guy has to be either plus or minus 6. I would move the 1 over, 2x equal to 1 plus or minus 6. And you divide both sides by 2. So when x is equal, so we get plus. When we have plus, we have 1 plus 6 divided by 2. That's 7 divided by 2. And when you have negative, it's 1 minus 6, which is minus 5, divided by 2. Okay, so that's how you would do that. Okay? All right, and that's the end of P.5.